Welcome to this special explainer. Today, we're taking a seriously mind-bending journey. We are going to start with the everyday objects right around us, the things you can actually touch, see, and feel. And we're going to travel all the way down into the fundamental physics that literally holds them together. So get ready to completely shift your perspective as we unpack the hidden secrets of the atomic world.
Okay, let's just dive right into this. Take a look around you right now. Think about the water you drink, the air you're breathing, or honestly, even your own body. What is it all actually made of? I want you to imagine zooming in infinitely small. Picture zooming into a single tiny drop of water, or maybe the shiny surface of a gold coin. If we keep zooming in, way past the microscopic level, we eventually hit the atom. And right there, dancing around inside that atom, we find its absolute most agile, restless, and fascinating inhabitant.
Say hello to the electron. It's a subatomic particle, and it is the foundational building block of literally every single atom in the entire universe. Now, we owe our knowledge of this tiny little marvel to a brilliant scientist named J.J. Thomson. Back in 1897, Thomson was messing around with this thing called a cathode ray tube, which is basically a sealed glass tube with all the air pumped out that shoots a glowing beam of light. And through that specific experiment, he brought this totally invisible, fundamental piece of our reality into the light for the very first time.
All right, moving into Section 1, the physical identity, exploring charge and mass.
So let's talk about what makes an electron, well, an electron. It carries a very specific negative charge, negative 1.6 times 10 to the power of negative 19 coulombs. I know, that massive negative exponent is a lot to wrap your head around, but it basically represents an infinitesimally small yet intensely powerful electrical charge. And this specific negative charge is absolutely crucial because it defines exactly how the electron behaves. It's what constantly pulls the electron inward, keeping it deeply attracted to the positively charged proton sitting right in the center of the atom. It's like this endless, high-speed cosmic dance of attraction.
And then we have its mass, 9.1 times 10 to the power of negative 31 kilograms. I mean, it's almost impossible for the human brain to even comprehend a number that tiny. What this essentially tells us is that the electron's mass is basically negligible. Compared to the rest of the atom, it is practically weightless.
To put that into perspective, imagine a traditional weighing scale. On one side, you drop the heavy proton, which sits firmly in the center of the atom. On the other side, you place our little electron. The heavy proton easily, and I mean dramatically, tips the balance. In fact, the electron is roughly 1,836 times lighter than just a single proton. So the atom carries almost all of its weight right there in its core, while these impossibly light electrons just flutter around the outer edges.
Okay, let's move on to Section 2, the spatial reality, from orbits to quantum clouds.
For the longest time, the old way of thinking was this solar system model. We picture electrons neatly orbiting the central nucleus, exactly like planets orbiting the sun, traveling in these fixed, fast-moving rings or shells that scientists named K, L, M, and N. It was all very orderly, very predictable. But then, along came quantum physics and the modern view. It turns out, the real picture isn't a neat little solar system at all. It's actually a mind-bending, blurry, hyper-fast electron cloud.
Here is the wild part about this modern electron cloud. We can really only guess where the electron might be at any given moment. The electron doesn't smoothly glide along some fixed track. No, it moves so incredibly fast that it seems to flash everywhere all at once around the nucleus. It forms this continuous, blurry cloud of pure probability. You literally can't point to a spot and say, "Aha, there it is." We can only map out a foggy cloud of where it most likely is at that exact millisecond. It's just a beautiful, chaotic storm of energy.
Which brings us to Section 3, the real-world impact, how electrons power our lives.
Now, to understand how this creates electricity, we first need to define a very specific group of electrons called valence electrons. These are the electrons that live way out on the very edge, orbiting in the absolute outermost shell of an atom. And because they're the furthest away from the center, that magnetic pull keeping them tethered to the atom, it's at its absolute weakest. So they are primed, they are highly energetic, and they are totally ready to break free if you just give them the right push.
So here is how that flow actually works in the real world. Step 1, imagine a standard copper wire. Inside that wire, billions of copper atoms have these valence electrons just sitting in their outer shells. Step 2, you apply a little bit of energy or voltage, and boom, these outer electrons break free from their specific individual atoms. And finally, step 3, they begin to flow completely independently down the wire. This highly dynamic cascading flow of runaway valence electrons, that is exactly what creates an active electrical current.
And that leads us to this really profound realization. The electricity running through our homes today is literally nothing but the flow of these exact electrons. Every single light bulb, every refrigerator, every massive data center powering the internet, our entire modern human infrastructure relies completely on this invisible subatomic concept. We are essentially just harnessing the incredible urge of these tiny, almost weightless particles to break out of their atomic clouds and just flow.
So I want to leave you with this final thought. Take a second right now to just stare at the screen you're watching this explainer on. Can you actually imagine it? Behind that glass, powering every single one of those pixels, are billions of invisible, almost completely weightless clouds of electrons, flowing and flashing at impossible speeds. The deepest, most complex mysteries of quantum physics are literally right there at your fingertips, making this exact moment possible. Pretty wild to think about, right? Keep wondering, keep learning, and I'll catch you in the next explainer.